This is Maya Breitenstein,
Caitlyn Flaherty,
Jiang,
and Bonnie Klopfer. We are working with Sodexo, Pitt's dining service, to optimize the University of Pittsburgh's reusable container program. Each month, the University of Pittsburgh disposes 225,000 single-use to-go containers. The university released a sustainability plan in January of 2018, which outlined its goal of serving 50% of all to-go meals and beverages in reusable containers by 2025. In fall of 2017, the university's dining services provider, Sodexo, partnered with reusable container manufacturer Aussie to implement Aussie's patented reusable container collection system at Shenley Cafe in the William Pitt Union. Through this system, a customer asks for their meal to be placed in an Aussie container and pays a 99-cent buy-in fee for their first container. Upon finishing their meal, they will return their container to the Aussie machine in the Shenley Cafe at their convenience and receive a token. They will then use this the next time they purchase a meal to have it placed in an Aussie container.
Too few Aussie containers are being used to get the university to its 50% goal. From its installation in the fall of 2017 to the fall 2018 semester, only 543 Aussie containers have been sold. To put that into perspective, there are on average roughly 31 Aussie containers used per month, so that is less than 1% of monthly containers used at the university. This leads our team to believe that many factors are at play for low container sales, but most notably, the location of the Aussie machines seems to not be optimal, so we'd like to determine the location and the number of Aussie receptacles that would result in increased demand. The data we received from Sodexo gave us the product totals at each dining facility on campus for the fall 2018 semester. Each row corresponds to the total amount of purchases of a specific product at that specific dining facility. We started with roughly 1.8 million entries, however, not all the entries are relevant to our project, so we condensed the data to only products sold that could be used in an Aussie container. Entries highlighted in red are products that were eliminated from the dataset. We eliminated restaurants that are unable to participate in a reusable container program like Taco Bell, Pizza Hut, and Chick-fil-A. There were also miscellaneous non-food grocery items like personal care items and cleaning items. We also went through and eliminated any pre-packaged items like candy, chips, and bottled drinks. We also had to eliminate any fountain drinks as Pitt currently is not looking to use Aussie for soft drinks at this time. This reduced our product sum to 483,423 and gave us an appropriate population to use for our future model.
In addition to the cash register data, we conducted a short survey to provide us with the data we need for the model. The survey asked basic questions about eating habits on campus, such as where you eat most often. To fit our model, Pitt's campus was divided into 6 separate zones. The zones were chosen based on potential areas where an Aussie machine might be placed. We closed our survey at 135 responses. Because our responses ended up being skewed to favor engineering students, we weighted responses for each school using a decision matrix so they would reflect actual proportions of the student body. After adjusting the survey data to represent the reality of the population distribution of the school, we were able to run our model and solve it to return values for the objective function defined in our model. These values represent the cost of placing an Aussie machine at a given location.
In order to determine the optimal location for the Aussie machines, we built an operation research location model. We use survey data to determine the alpha value of 85%, the percent of people who are willing to use Aussie. Additionally, we use the variable Pij and Qij to represent the percent of people flowing from location I to location J and the percentage of that group who will return the container. A basic explanation of the model intuition is depicted in this diagram. A customer buys a meal with Aussie at location 1 with some probability P12, the customer moves to location 2 to eat their meal. Finally, with some probability Q23 and Q24, the customer goes to location 3 or 4 to return the container.
Here is an example of one of the matrices that was used to build our model. Again, P of ij represents the percent flow from location I to location j. Therefore, the circled value of 0.146 represents the probability that a customer will move from zone 3 to zone 4. Each row of probabilities will add to 1. With this matrix and others similar, the model was formulated in GAM software and solved using Barron Solver.
From the model results, we found that Litchfield Towers was the optimal location for the next Aussie machine. We noted that Towers is in the same zone as the William Pitt Union, which already has an Aussie machine. This intuitively makes sense because of the demand concerns. Our next placement recommendation is at the Cathedral of Learning, with Sutherland Hall, Wesley W. Posvar Hall, and Benedum Hall following. These recommendations for Aussie machine placement will help to optimize the University of Pittsburgh's monetary input towards campus sustainability.
If we encourage 30% of people to use Aussie, the sustainable return will be greater than the cost of buying one machine. This level of participation is feasible for the university, as our survey indicated that 85% of responses are willing to participate. To obtain the greatest sustainable return, the Aussie program and location should be marketed to increase Aussie demand. Furthermore, dishwashing flows for the Aussie containers should be scheduled accordingly based on Aussie location and demand levels. A cost-benefit analysis should be explored to quantify sustainable aspects. To maximize use of the program, the university should expand Aussie use to different products, including beverages and utensils.
We thank Dr. Luang-Kisorn and Dr. Clark for their technical support with this senior design project.
We would also like to thank our sponsor, Nick Goodfellow, for giving us the opportunity to work on this project and contribute to the University of Pittsburgh's sustainable goals.
Additionally, we'd like to thank the CEO of Aussie, Mr. Tom Wright, for visiting Pitt's campus and helping us maximize Aussie's impact on our campus.